Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BVD ITM Lucknow. We will take up foundation engineering today, in which we will cover lecture 32, sheet pile. References that I have taken: Dr. B.C. Punamiya, Soil Mechanics and Foundation, V.N.S. Murthy, Soil Mechanics and Foundation Engineering, Alam Singh, Soil Mechanics and Foundation Engineering, Dr. R.K. Arora, Soil Mechanics and Foundation Engineering, and some material have been taken from internet. Today we will cover introduction of sheet piles, steel sheet piles, cantilever sheet pile, free cantilever sheet pile, fixed cantilever sheet pile, cantilever sheet pile in coaseless soil, ASP with free earth support, steel sheet pile, ASP with fixed earth support, advantage of sheet piles, disadvantage. So, first of all, we come to the introduction of sheet pile. What is sheet pile? Sheet pile wall have been used to support excavation for below grade parking structure, basement, pump house and foundation, to construct cofferdam and to construct sea walls and bulkhead. Permanent steel sheet piles are designed to provide a long service life. Sheet piles are section of sheet material with interlocking edges that are driven into the ground to provide earth retention and excavation support. Sheet piles are most commonly made of steel, but can also be formed of timber and reinforced concrete. Now, the type of sheet piles walls based on material. So, there are three types of sheet piles based on material. First is a timber sheet pile. These are generally used for temporary structure and breast sitting in excavation work. Of course, that is also a temporary. Second is concrete sheet piles. These are precast concrete member, usually joined by tongue and groove joint. And third is a steel sheet pile. Steel sheet piles are most commonly used. We can see here this is a sheet piles. This is made of timber. We can very easily see this is a trench has been dug, and to support the side earth, a timber sheet piling has been done here. Then this is the another sheet piling, that is a concrete sheet piling, which is provided to support the earth on other side. You can see very easily in the picture. The next is a steel sheet pile. It is quite visible that this is the sheet in the corrugated shape, like a corrugated shape, and anchored each other, and is that will support the earth and other material like even a water for the permanent construction. So, this has more life than the timber or concrete sheet pile. Many wood sheet wall follow the navy wall design concept, where load are transferred to round timber master piles and standard dimensional lumber is used for sitting. The interlocking system devised for timber or concrete sheet piling have been based on tog and groove concept. This method serves to keep the wall aligned while providing a longer path against infiltration with more potential contact point than a simple butt joint. The concrete sheet pile are prefabricated to eliminate the necessity for temporary wooden or a metal form work at site. This method can quickly and safely construct a strong, high quality prefabricated structural wall. A steel sheet pile is rolled steel section consisting of a plate called wave with integral interlocks on each edge. The interlock consists of a groove. One of those legs have suitably flattened. The flattening form the tongue which fit into the groove of second sheet. So, we can see here this is the steel sheet piles, and suppose this is one sheet and we can see here there is a groove here, there is also a groove of this sheet and another sheet have a opposite direction groove like this way. This both will fix together when they are attached to each other. So, we can see here this is a DR, this is the specification, this is 376 mm, 600 mm from here to here, this has 116 mm, this has 61 mm, 600 mm, this is a B2, this is B4, the B5, this is 9 mm, 310. So, this is a detailed specification of a steel sheet pile. The main thing of this sheet pile is fixing of two sheet piles together, and for this purpose we can easily say this one and this one how this will attach to each other. This is a detailed drawing of a typical steel sheet pile. Now, come to the cantilever sheet pile. Based on its structure, form and loading system, sheet piles are classified in two types. One is called cantilever sheet piles. Cantilevered sheet piles wall is one of the most famous flexible retaining structure that usually used secured deep excavation down to about 5 meter. It could be constructed using a steel profile or tangent pile, driven precast or board pile. Cantilever sheet piles are further divided into two parts. One is free cantilever sheet pile. It is a sheet pile subject to a concentrated horizontal load at its top. There is no backfill above the dredge line. The free cantilever sheet pile derives its stability entirely from the lateral passive resistance of soil below the dredge line into which it is driven. So, we can see here this is a free cantilever. What happened? This is a dredge level and a sheet is fixed inside the below the dredge line. A horizontal force you can see here easily. This is the horizontal force F is acting towards the dredge line. Okay. So, here we can say this is the cantilever sheet pile, this is the one dredge line of course, and sheet is provided to protect earth from this side, and this is the backfill is here from up to here. So, this is a cantilever piles. Now, for the better workmanship, anchored sheet pile is used. This is a dredge line, the pile is sunk below the dredge line and they are used to protect backfill from the pile. Because its height is too more, so it is very difficult to counteract the force acting on this sheet pile. So, the top portion of this sheet pile is anchored here with a sub block and this will counteract the forces developed due to backfill. Now, come to the free cantilever dredge sheet pile. We can see here F is acting towards the dredge line and this is R d K p, this is a coefficient of passive earth pressure, coefficient of active earth pressure. So, K d will be into K p minus K a, here also gamma d K p minus K a. So, this is the active and passive earth pressure. This is the depth of the sheet pile below the dredge level. Here F is acting towards the dredge line. So, this is the actual pressure distribution of a sheet pile. We can see here this again assume pressure distribution. Here is the this is the point where say this is the point x from the dredge level. So, pressure is acting towards this side and this is the passive forces acting towards against the pressure acting to this side. F is the force acting towards the dredge line. Here the value is gamma d K p minus K a. So, we can see here this is the pressure distribution of a sheet pile. Now, this is the diagram of moment and we can see here from top or bottom the moment is going to increase from top or either bottom. The maximum moment could be attained at this point, that is the x from the dredge line. Now, come to the next one, cantilever sheet in the cohesion-less soil. So, we can see here again because it is a cohesion-less soil. So, the sheet will behave like this way. This is a dredge line, this is the passive forces acting on the sheet, this is the active forces, active pressure acting on the sheet. The point of this is the point of rotation. In this case, the sheet will rotate at the bottom point of the dredge line. So, here this is the actual pressure distribution and we can see here this is the height h, this is the d and what happened, this is not a straight line, but it is a curve like this one. Now, come to the this is the cohesion-less soil. So, here C will be 0. Okay. So, P active forces acting at Z 1 bar. This is the dredge line and again the depth of dredge level is d. The passive forces acting towards the pile in the below the dredge line, because the this is the cohesionless soil. So, phi here C 1 is equal to 0. If it is a clay, then phi will be 0 and cohesion will be C. So, this is the pressure distribution chart of cohesionless soil. Now, cantilever sheet pile. Cantilever sheet piles, a cantilever sheet piles retains backfill at a higher level on one side. The stability is entirely from lateral passive resistance of the soil into the which the sheet is driven, like that of free cantilever sheet pile. The cantilever sheet pile are used where the height of soil or water to be retained is a smaller than 4.5 meter. The various forces acting on a cantilever sheet pile wall are active earth pressure on the back of the wall and passive earth pressure on front of the wall. So, here we can see this is the anchored sheet pile with free earth support. So, again here this is the anchor, the sheet is flexible. So, this will behave like this way. This is the anchor point which will anchor the seat to this, this is a fixed point. This is the dredge level, the depth is d, P2 is acting below the dredge line, and the bottom is gamma Kp minus Ka into B. B is the width of the dredge. This is the pressure, bottom pressure at this level. So, we can say here, and this is the eccentricity, E is the eccentricity. So, here P 1 is equal to K A, active pressure, coefficient of active pressure into H. H is the height of backfill. So, this is the pressure distribution of anchored seat pile with free earth support. Now, come to this one. Here C is equal to 0, means this is the cohesionless soil. So, again you can see here the active forces acting behind the seat pile. Passive forces is acting below the dredge line, and the value of P here, the pressure, is K A gamma H, where phi is equal to 0. This is the P 2, this the depth is d. So, this is the pressure diagram of the free earth support anchored seat pile. Anchored seat piles are bulkhead which is held above its driven depth by one or more tie rod or anchor at or near its top. The anchor provide forces for the stability of the seat pile, in addition to the lateral passive resistance of the soil into which the seat pile are driven. These are also of two types, but this type of seat piles are two types. One is free earth support piles and fixed earth support piles. The anchored seat pile is said to be have a free earth support when the depth of a embedment is small and the pile rotate at its bottom tips. Thus, there is no point of contrafracture in the pile. The fixed earth support piles, anchored seat piles has fixed earth support when the depth of embedment is large. The bottom tips of the pile is fixed against rotation. This is the difference between the free earth support and the fixed earth support. There is a change in the curvature of pile and hence an inflation points occur. So, we can see here anchored seat pile, and this is the condition that we have already discussed. Now, come to the advantages of seat pile. So, seat piles are recyclable and reusable. Piles can come in a wide range of length, size and a steel option. They can be used for temporary and permanent structure both. They can be installed using silent and vibration free method. The work is neat, clean and create no spoil arisings. the supervision of work on the site can be reduced and minimal storage space is required. The seat piling is more cost effective and quicker installation than continuous or second wall. Coffer dam can be constructed in almost any desired shape. However, for the practical and economic reasons, most coffer dams are either rectangular or circular. Seat piles can provide a close fitting joints to form an effective water seal. They have a long life above or below the water, making them advantageous for marine and coastal structure. Anchored seat pile walls can provide even more flexibility for the installation purpose. We can think, because we are using a costlier seat piles, whether this could be removed or not. So, after the deep foundation pits is backfilled, the steel pile seat pile shall be removed to facilitate repeated use. Before pulling on the steel seat pile, the sequence of pulling out method, piles pulling conditions and soil holes should be studied carefully and scientifically. Driving assistance method can significantly improve the constructability of a seat pile wall. Jetting and pre-augering are the main methods. Jetting involves delivering of water jet to the soil at the toe of the seat pile, reducing the friction. Now, disadvantage of the seat pile. If the soil is rocky or has a large boulder, it becomes difficult to install a seat into it. If you are going to use vibratory hammer or impact hammer to install the seat into the ground, this can cause neighborhood disturbance. Most of the seats are used as a temporary structure. So, this is the end of the seat pile. We can say thank you very much. Thank you.